Welcome back. We're in Momentum, Worksheet 2, problem number 7. At the intersection of Ogden Avenue and Eola Road, a small car of mass 900 kilograms traveling east on Ogden collides with a pickup truck of mass 1,500 kilograms that is traveling north on Eola. Two vehicles stick together, and immediately after the collision, the wreckage is sliding at this amount, 24 degrees east of north. Determine the speed of each collision of each vehicle before the collision. Okay, so this one we definitely need to draw a picture. We clearly see that the action here is this collision here. I'm going to go ahead and draw a top-down view here of these two roads. Now, if you're familiar with Ogden and Eola, you would know that these don't actually intersect at a 90-degree angle, but for simplicity of this, I'm going to go ahead and approximate them to do that. So here we have north, south, west, and east here. And so we know that we have, which way is this going? So Eola is going this way here. I'll write that on here, Eola and Ogden. So I don't get confused, because I do get confused easily. Yep, and so then the school is right here, WVHS. Okay, so we got the gas station over here. We got Fisher Middle School here, and then there's like the Wendy's and such over here. Big Apple Bagel. Okay, so let's put the cars in here. Small car traveling east on Ogden. So here's the small little car. Oh gosh. Here's the small little car. Put C for car. It's traveling east. V0. And a pickup truck that's much bigger. Draw that. This will be T for truck. They're going north, right? Traveling north at Eola. There's V0. VT0 maybe. And then afterwards, maybe I'll just draw that on here. Afterwards, here's their wreckage. Their wreckage is going to be the one car smashed into the other car. That's the wreckage. They are sliding 16 meters per second, 24 degrees east of north. So this direction is the velocity afterwards. And let me go ahead and do a dotted line of north in there. So now that's 24 degrees east of north. Looks like that, 24 degrees. Okay, cool. Determine the speed of each vehicle before the collision. Well, we look at that and we go, hey, hold on a second. I just did component vectors of, or I mean, didn't I just have a velocity that's at an angle there? Don't I need component vectors of any vector at some angles there? And I'd say, yeah, we do. If I have 24 degrees there, I know that I have 24 degrees there. And so now I can see that this is going to be V times the, we'll say, sine of 24, and V times the cosine of 24. Okay, cool. So now I have my Vx and Vy, you might say. And this problem is a little bit different because we have things going in 2 dimensions here. And so we have a collision that's happening in 2 dimensions there. So when I think about this, I'm going, hey, I have momentum going west and east, and I have momentum going north and south. And I know that one dimension is independent of another dimension. So I'm going to be doing 2 different calculations here. I'm going to be doing like an x momentum, maybe I'll write that as momentum in the x direction, and separately I'm going to be doing momentum in the y direction there. Okay, before I go and do all of that, let's go ahead and let's define our system. I'm going to make the system both the car and the truck, so then it's everything combined. So I know that the change of momentum in total here must be 0, meaning that the beginning momentum has got to be equal to the ending momentum. Well, let's look at that in the x direction. In the x direction, I know that the beginning momentum is going to be equal to the ending momentum. And separately, I know that's going to be true in the y dimension there as well. Okay. Now, since I'm working under the x and y columns there, I'm going to drop these subscripts of x there. Well, in the x direction, the only thing I have is the mass of the car times the velocity of the car in the x direction at the beginning. And at the end here, well, I have both of these guys are going together, so I'm going to immediately can combine them. So I have like the mass of the car and the mass of the truck there. And then it's multiplied by their velocity. I'll just put it as v with no subscript there since I did that on my picture. But it's in the x direction, and that's v times the sine of 24. Gosh, sine of 24 degrees. Separate these guys. Okay, let's look in the y direction. In the y direction at the beginning, it's just the truck there, so that's the mass of the truck times the velocity of the truck at the beginning. I didn't put the car at the beginning there. Okay. And then afterwards, it's those guys that are moving together now. And the velocity that's going in the y direction is v cosine of 24. You might say, can't I use the other complementary angle of 24? And I'd say, sure, go for it. Workout would be the exact same. So yeah, let's see. Let's look at this. Do we know the mass of the car and the truck? Yep, it gave it to us. Do we know the velocity afterwards? Yes. Do we know the velocity of the car beforehand? No. Do we know the velocity of the truck beforehand? No. So I have one variable in each of these equations that I don't know, and so now we just go and we solve. So let me put in all of the numbers here and grab my calculator. So it's 900 for the car, 15 for the truck, and 16 afterwards. So 900 kilograms for that. We don't know VC naught. And then it's 900 plus 1500, which gives us 2400 times 16 sine of 24 degrees. And 16 sine of 24 times 2400 divided by 900. Make sure I'm in degrees. And so I get the velocity of the car at the beginning to be 17.35 meters per second. And we'll do the same thing over here, except this is 1500 VT naught is equal to still 2400. Did I do that right? 1500 plus 900? Yeah, it's 2400 times 16 cosine of 24. VT naught, 2400, 16 cosine of 24 divided by 1500. I get 23.39 meters per second. Okay, so that's the velocity of the car and the truck beforehand. Let's see if this makes sense. 24 degrees is that one. So I know that the Vy is going to be bigger than the Vx afterwards. So you're going to have more momentum since it's one object that's, let me point with the pen, since it's one object that's moving, and I recognize that this velocity vector has got to be bigger than this one here because of angles and how triangles work, then we have more momentum going upwards than we do going left and right, or more momentum going north than we do east. And here, I can see that I definitely have more momentum going north ahead of time. The velocity is bigger, and the mass of that truck is also bigger. Okay, cool. Sweet. So that at least overall checks out here. Okay, cool. That's it. If this was happening in 3 dimensions, guess what you would do? Same thing. You just have PZ over there and in one more dimension, but it's all the same, just like that. Have a beautiful day. See ya.